Welcome to this video on constructing a confidence interval for one mean with data. Let's begin. Suppose you are a public health researcher working for a city tasked with determining the average amount of water consumed per day by the residents. You want to estimate the average water consumption for the entire city, but can only measure the consumption of a random sample of households due to time and resource constraints. You select a random sample of 50 households from across the city and measure the amount of water used per day in gallons. Construct a 90% confidence interval for the average daily water consumption of the entire city and round all values to the nearest gallon. When you log into RGuroo, your screen should look something like this. So we're going to go to Analytics, Analysis, Mean Inference, One Population. Then we have to tell the computer what dataset we're using. So the name of the dataset I'm using is called Daily Water Usage Gal, meaning gallons. So let's select that dataset. Now, from that dataset, I have to tell it which variable to use. There's only one column of data, and that's this one. So I will select that one. So now I have to go down here to the bottom of the page, and I have to change my other parameters. So I want to change my confidence level from 95 to 90 because the problem asked for a 90% confidence level. And then I need to tell the computer that I want to perform a t-statistic since the population standard deviation is not being provided. Now, you can leave this here. This is an automatically populated label, the daily water usage in gallons. But if you were doing this for, say, a project or something that's really nice, that you really want it to look beautiful, you could retype it. So daily water usage in gallons. Okay, again, this is just an extra step depending on your application. So if it's something that's really nice and it needs to look beautiful, you can retype it. If it's just a homework problem and nobody's ever going to see the output, then you don't need to change that. All right, so let's go ahead and hit the eyeball and see what happens. Okay, so notice it goes ahead and summarizes my data, and it tells me, well, my sample size is 50, my mean water usage is 225.84 gallons, and the sample standard deviation is about 27 gallons. Then we come down here, and the lower limit is about 219, my upper limit is about 232 gallons, and my margin of error is about 6.4. So that is all the information that I need to create my confidence interval and then write a summary statement. Let's take the information that we found and use it to construct a confidence interval. So recall that a confidence interval consists of a lower limit and an upper limit. Halfway in between them is our point estimate, and then we have the margin of error. So RGuroo told us that our lower limit was about 219 gallons, our upper limit is about 232 gallons, and our point estimate is about 225 gallons. Our margin of error was about 6 gallons, but I do want to point out something here. If you take 219 and add 6, you get up to 225. But if you take 225 and add 6, you only get up to 231, and that might upset you a little bit. And what's happening here is very simply just rounding error. And the only way around this is just to add more precision to all of your values. Okay, but just note, it's just because we rounded. It's not because we don't know how to do math. So here is my confidence interval. So let's go ahead and summarize our findings. So we will say that we are 90% confident that the average daily water consumption in the city is between 219 and 232 gallons. So remember that I just literally pulled the verbiage straight from the question, which says average daily water consumption of the entire city. I didn't have to think at all. I just plopped it right in my answer, and then again pulled in the lower and upper limit. The other thing to always remember is it's very important to put in your units. You've probably spent most of your schooling working with numbers and not worrying about what they mean. But now we're in statistics and everything has a meaning. And so we have to think about, well, 219 watts, 232 watts, what are we measuring or what are we counting? And the answer is that we're measuring a volume of water, we're measuring gallons.